Hi students, today we are going to tackle the two-sum problem. It's a classic coding challenge that often appears in interviews to test your problem solving skills. Stick around and you'll soon conquer the two-sum like a pro. First, let's understand the problem. The problem statement says, given an array of integers and an integer target, return indices of two numbers such that they add up to the target. That means we have an array of numbers and we have to find indices of two numbers x and y such that x plus y is equal to the target value that is given. So what are the other conditions we have? You may assume that each input has exactly one solution, which means the solution is always guaranteed and it's only one solution, not 0, not 2, exactly 1. And another condition is you may not use the same element twice, which means we cannot repeat the number in the solution. Let's go through the examples. So the first example is array 2, 7, 11 and 15 and the sum is 9. The output is 0, 1, which is 2 plus 7. 2 plus 7 is 9. So that is the output. In the second example, array is 3 to 4 and target is 6. So 3 plus 3 is also 6. But since we can't repeat the numbers, that cannot be the solution. So the output is 1 and 2, which is 2 plus 4, which is 6. In the third example, the numbers are 3 and 3 and the target is 6. Numbers can repeat, so this is a valid input. 3 plus 3 is 6, that is why the output is 0 and 1. So let's go through the solution with an example. So we have to find two numbers such that target is 8 in the given array, which is 3, 4, 9, 6. Okay, let's say we are at 6. Okay, we have to find a number in the already seen array such that 6 plus that number adds up to 8. That is the question, right? Which means 6 plus y equal to 8. Which means we have to find if y equal to 2 exists in these three, which doesn't exist, so 6 can't be a solution. Similarly, if we look at 4, okay, then we will be looking at the remainder of the array, the whole array. In this case, 4 plus y equal to 8, which means y is 4. We are looking for another 4 in the remaining array. We have a 4 here and we are currently here. So 4 plus 4 is 8, which is why for this the solution would be 1, 0, 1, 2, 3, 4. 1, 4. So let's go over iteration by iteration. So see, clearly we need two loops here. So in the first loop, we start at element 3. So I equal to 0 and j is equal to I, which is 0, but j is less than I. So in the first iteration, it's just one element, so there is nothing to compare. So we just go to the second one. In the second iteration, I would be 1 and j can take values. J is less than I, so j can take only 0. So in the second iteration, when I is here, I is 4, I is at 4 and j is at 0, 3 plus 4, 7, that is not the solution. We will continue. In the third iteration, I is at 2 and j can take values. J is less than I, so 0, 1. 9 plus 3 is 11, that is not the solution. 9 plus 4 is 13, that is also not the solution. So let's go to the next iteration. Fourth iteration. In this iteration, I is 3 and j is 0, 1 and 2. Okay, so when I is 3 and j is 0, 6 plus 3, 9. That solution is not possible. When I is 3 and j is 4, j is 1, 6 plus 4, 10. When I is 3 and j is 2, 9 plus 6, 15. None of them are solutions. So we go to the next loop, which is I equal to 4. We also reached the end of the array here. So we should definitely find a solution because the problem statement guarantees that there is exactly one solution. So here I will be 4 and j can take values 0, 1, 2 and 3. So I is 4, 4 plus 3 is 7, that is not the solution. When I is 4 and j is 1, 4 plus 4 8, so that is the solution and we break at that. So we get the indices 1 and 4. Okay, let's look at another example for this. Let's say this is the given array and the target is 5. So in the first iteration I is 0, j cannot take any values, so we just go to the second one. Okay, in the second iteration I is 1 and j can take value 0, j is less than I. So 5 plus 3 8, it's not equal to 5. So we go to the third iteration. Here I increments, so I is 2 and j goes from 0 to less than I, so 0 and 1. So I is 2, j is 1 plus 3 4, so that is not the solution. When I is 2, j is 1, 5 plus 1 6, so that is also not the solution. Now let's go to the fourth iteration, that is when I equal to 3, which is I is here. Now j values are 0, 1 and 2. So when I is 3 and j is 0, 4 plus 3 7. When I is 3 and j is 1, 5 plus 4 9. When I is 3 and j is 2, 4 plus 1 5. So that is our solution. I is 3 and j is 2. Okay. So here notice that there is minus 8 and 3. Minus 8 plus 3 is minus 5, not 5. So that cannot be a solution. Okay. So let's try and write code for this solution. Okay. So this is a Leetcode problem. So we will go to Leetcode and code there. Okay. Leetcode 2sum. The simple search will give you the Leetcode problem. So here I am going to use Java for coding. So what were we doing? For we took two variables I and j, and one variable is going from 0 to size of array. Okay, and the other variable is going from 0 to I. Okay, what are we comparing here? If nums of I plus nums of j equal to target, then we found the solution and we have to return an integer array of I and j. If this didn't happen, we have to have a default value. Problem statement guarantees that there can't be this scenario. That is why we will just throw illegal state exception. This will never happen. Okay. So we are going from I equal to 0 to size of the array, j equal to 0 to j less than I. So j less than I, so when they are 0, the first round would be skipped. When it is 1, it will keep comparing all the history items. Let's run with the sample test cases. Okay, the test case pass. Let's submit and see. Yes, this is giving the desired solution. Let's see what is the time complexity of this solution. So here what are we doing? We have two loops, one going over the one with I, which goes over nums dot length, and another with j, which also in a way goes to nums dot length. So here this solution has a time complexity of, there are two loops, one within the other, so order of n square. where n is the size of the input, whereas space complexity, we are not using any additional variables, so it's just a constant space. Okay, so order of n square is pretty bad. When the array size is very huge, it will fail badly. So let's see if we can improve this solution. So usually when you are looking at array problems, when you are thinking of improvement, usually sorting or hashing helps. Okay, so here if you see, what we are doing is we are traversing the array and seeing that in whatever history we have seen, we are trying to find an element matching our equation. Okay, so maybe the find thing, we can use a hash map and improve the solution. Let's see. So we will still have one loop, which is I. So in the first step we have I equal to 0, and we also have a hash map. Okay, I equal to 0, there is nothing in the hash map at this point, so we will check if 5 minus 3, which is 2, is in the hash map. So we are basically checking if any of our history is in the hash map. At 3 there is no history because we are at start, so there is nothing to check actually. So in the second iteration, when I is 1, which is we are here, okay, no, so in the first step we didn't find the element, but when we didn't find, we have to put this element in hash map so that the next comparison becomes easier. Okay, so when at I equal to 0 we didn't find 2, which is 5 minus 3. So what we will do is we will just put 3 in the hash map. So 3 is at index 0. Okay, so when we are at 1, which is 5, 5 minus 5, 0. We'll try to see if 0 exists in this hash map. No, there is no 0. So what will we do? We will put 5 in the hash map. 5 is at index 1. Then in the third iteration, I becomes 2, which is here. So here our x is 1, 5 minus 1 is 4. Is 4 in the hash map? No, not there. So what we will do is, sorry, this should be 1. We will put 1 in the hash map. 1 is at index 2. Then in the fourth iteration, I is 3, which is here. Okay, so x is 4, target is 5, y should be 1. So in the hash map we will check if 1 exists. Yes, 1 exists. 1 is at index 2. So our answer is 2, 3. Okay, let's see this hash map solution with another example. Okay, here this is the array we have and the target is 1. So in the first iteration, I is 0. Okay, our hash map is initialized to empty. Okay, when at 0 we won't find an element, so we will just put 4 at index 0. Okay, when we come to the second element, which is I1, index is minus 2, target is 1, so we are looking for 3. 3 doesn't exist, so we put minus 2 in the hash map and we continue. So in the third iteration, I is 2, which is we are here, and we are looking for 1 minus 5, which is minus 4, which doesn't exist, so we just put 5 in the hash map and we continue. Okay, next in the fourth iteration, I is 3, okay, which is here. Okay, 1 minus 0, we are looking for 1, which doesn't exist, so we put 0 in the hash map. Okay, so far we have put all the elements in the hash map. 4 is at 0, minus 2 is at 1, 5 is at 2, 0 is at 3. Next, in the fifth iteration, I is 4, which is we are here. Okay, 1 minus 6, we are looking for minus 6, 1 minus 6, sorry, minus 5, minus 5 doesn't exist, so we just put 6 in the hash map. Okay, in the next iteration I becomes 5. Okay, we are at 3 and we are looking for 2. 3 doesn't exist, so we just put 3 in the hash map and we continue. No, that's not correct. So when we are here, when I equal to 5, 1 minus 3, we are looking for minus 2. Minus 2 exists in the hash map. Okay, minus 2 is here, so our answer is 5 comma 1. Okay, so when we are at 3, 1 minus 3 is minus 2. We are looking for minus 2. Minus 2 already exists, so our answer is 5 comma 1. Okay, let's try to write code for the hash map solution. Okay, so let's reset it. Oh, okay, so we need only one loop here and we have to create a hash map. Hash map, it is integer comma integer because it is having a number and its index. Okay, so when we are at I, what we look for, we check if map dot contains key nums target minus nums of I. Okay, if such a target exists, then we have a solution. We have to return it. Return new int I and map dot get of target minus nums of I. Else, if this is didn't happen, then we have to put the current element in the map so that it makes it easier to search for the next element. So what do we put? Map dot put nums of I and its index, which is I. So a solution will definitely, we will definitely find a solution, which is why this state is not possible, and here we are just throwing the exception to keep the compiler happy. There is a typo, new integer. Okay, so let's submit and see. Yeah, if you see here clearly, the previous answer took 37 milliseconds, whereas the current one took just 1 millisecond. So with this hash map optimization, we saved lot of time. Now let's see the time complexity of this one. So we are having only one loop, so the time complexity would be just order of n. And the space complexity, we are using a additional hash map which is of the size of the input, so the space complexity would be order of n. Okay, that's all for today. If you enjoyed this session, give us a thumbs up and subscribe for more coding tutorials. And happy coding! I'll catch you in the next video.